In this video, we're going to learn how to balance half reactions as well as redox reactions in acidic conditions. So if the question doesn't say what type of conditions you're working with, you can assume that it's acidic conditions. But the 4 steps that we're going to follow are these. First step is we're going to balance all other elements except for hydrogen and oxygen. Then in step number 2, we're going to balance oxygen by putting water on whatever side it's needed. So essentially, you're putting water on whatever side has the least amount of oxygens. Okay, and that's if you need it. Step number 3, we're going to balance hydrogen on each side of the equation by adding hydrogen ions. And we can do that because we're working with acidic conditions. Okay, so you're going to go to whatever side has the least amount of hydrogens and add the H plus ions to balance it out. Okay, and then step 4, you're going to balance the charge by adding electrons on whichever side has the more positive charge to it. Okay, so with these steps here, I'm gonna color code them here. Okay, so light blue is gonna be step number 1. So step number 1, we're balancing out all other elements that are not hydrogen and oxygen. So looking at our first half reaction here, we're given phosphorus and it reacts to produce H2PO4 1-. Okay, so step number 1, we have to balance phosphorus. So there's four phosphoruses going in, so we need to have 4 coming out. So I'm going to put a 4 right here. So that 4 affects everything that comes after it. So we do have 4 phosphorus on our product side now, but we also have 8 hydrogens and we have 16 oxygens. Okay, so that was step 1. Let's do step number 2. So I'll do that in pink here. So we're going to balance oxygens. So as I said, over here we have 16 oxygens. Okay, and we don't have any oxygens on our reactant side. So we're going to balance it by adding water here. And it's going to be 16 waters because 16 times 1 oxygen gives us 16 oxygen. Okay? All right. So oxygen is taken care of now. So now we're going to move on to balancing hydrogens. Okay? So looking at our reactant side, we have 16 times 2. So that's going to be 32 hydrogens. And on the product side here, we have 4 times 2, so we have 8 hydrogens. Okay, so I'm going to the side that has the least amount of hydrogens, and that's where I'm adding my H plus ions. So I'm going to go over here, add my H plus ions, and I'm asking myself, okay, 8 plus what is going to be equal to 32, well, that's going to be 8 plus 24. Okay. All right. So now that we have that done, so let's get rid of this. All right, so step number 3, that was purple. So step number 4, we'll do that in green here. Okay, so essentially what we want to do is figure out what's the total charge from each side. So on our reactant side, since both of our reactants are neutral compounds, the total charge is going to be 0. Okay, over here, on my product side, so we have 4 H2PO4 1-, so we have 4 times -1, so that's -4. And then we have 24 H pluses, so plus 24. Okay, so that's going to give us plus 20. So when I look at the total charge on each side, I'm going to go to the more positive side, and that's where I'm going to add my electrons. And I'm going to add enough electrons so that both sides have the same total charge. Okay, so I'm going to add 20 electrons over on the product side. So that's going to cause this to go -20, which is 0. Okay, so both the reactant side and the product side have the same total charge now. So that's all good. Okay, last but not least, the question does ask us to determine the number of electrons lost or gained for the following half reactions by writing the correct number of electrons into each equation. And you may use the method of half reaction, balancing, or oxidation numbers. We're just focusing on half reaction balancing here. Okay, so looking at our half reaction here, I see that our electrons are on the product side. Okay, now the key thing that we want to remember here is if your electrons are on the reactant side, those are electrons being gained. But if they're on the product side, that means your electrons are being lost. Okay, so with this, because our electrons are on the product side, and because there's 20 of them, that means we lost 20 electrons. Okay, and that's it for this type of question. So I'll do one more example and then I'll be moving on here. Okay, so step 1, we need to balance anything that's not hydrogen or oxygen. So here I see there's one iodine on each side, so those are already balanced, so I can already move on. Okay, next we're going to balance out the oxygens here. So I see there's 3 oxygens on the reactant side, so I need to have 3 on the product side, and I use water to balance out the oxygens here. So plus 3 waters. Okay, so now that I have 3 oxygens both on the reactant and product side, now I'm going to balance the hydrogens here. So with the hydrogens, I've got 3 times 2, so I've got 6 hydrogens on the product side, so I need 6 hydrogens on the reactant side, and what I'm using to balance the hydrogens is H+ ions. Okay, so now I have 6 hydrogens both on the reactant and product side, so that's good. Now I need to figure out, okay, what's the total charge on each side? So total charge, so we have 1 minus coming from here. Okay, and then we have 6 positive 1 charges coming from here, so plus 6, that's equal to positive 5. And then on our product side, we have a -1, and then this will just be 0 because it's a neutral compound. So we have plus 5 compared to -1, so I'm going to go to the more positive side, and that's where I'm going to add my electrons. And I'm going to add my electrons so that both sides have the same number. So I'm going to add 6 electrons here, because if I do so, then what will happen is we'll have positive 5 minus 6, that gives us -1, and now we have the same total charge on both the reactant and product side. Okay, so to finish answering this question, I can say that since the electrons are on the reactant side, that means we gained 6 electrons. Okay, so this half reaction that we just balanced, that would be a reduction reaction, because remember, Leo the line goes grr. Okay, gain is reduction, or gaining electrons is reduction. So that's why the second example would be reduction, and then the first example would be oxidation, because losing electrons is oxidation. Okay, so we'll treat the rest of these as practice questions here. So now we can move on to balancing redox reactions using this half reaction method. Okay, so this page was pretty much just the warm up to the next page here. Okay, so this is when we're both going to have reduction as well as oxidation reactions happening at the same time here, rather than just one half reaction. Okay, so the steps that we're going to take in order to balance redox reactions using the half reaction method is we're going to take apart the equation into 2 half reactions, and then we're going to balance each half reactions using the steps that we just learned. Okay, so step 2, balance the atoms, any atoms other than hydrogen and oxygen after you've taken apart into the 2 half reactions. Then balance out oxygen by adding water on the side that has the least amount of oxygen. Then step 4, balance out the hydrogen by adding H plus to the side that has the least amount of hydrogen. Step 5, balance out the charge by adding electrons to the more positively charged side. And then step 6, we're going to add the 2 half reactions to cancel the electrons out. Okay, so both with these types of questions as well as these types of questions, you're not looking at page 7 of your data booklet. So page 7 is the one with the redox table in it. You're not looking at this to do these questions here. Okay, so with this first question here, I'm just going to pick it apart. And how I'm going to pick it apart into the 2 half reactions is I'm going to ignore the H plus ions and water for now, and I'm going to focus on anything else that is not H plus ions or water, because I know the whole purpose of water and those hydrogen ions, they're just to balance out either hydrogen or oxygen in each half reaction. Okay, so what I'm going to do for the first reaction, I'm going to ignore hydrogen and water and just focus on picking out other substances. Okay, so I'm noticing, okay, we got zinc, so I look on the product side and I say, okay, what looks kind of like this? Well, zinc 2 plus kind of looks like that. So that's one of our half reactions there. Okay, so I'm going to have zinc solid goes to zinc 2 plus. Okay, and then for the other one, again, ignoring those hydrogen ions and water, I'm going to say, okay, my other substance was here, so what else on the product side looks kind of like this? Well, this looks pretty similar. Okay, so I'm going to use that to build my second half reaction. And I'm making sure to line up the reaction arrows just because it does make it easier to see what's going on when things cancel. Okay, so step 1, I did that using purple. Now step 2, I'm going to do in light blue. Okay, so looking at my zinc half reaction, I've got 1 zinc on both sides, so I don't need to do anything to the first reaction. With the second reaction, I'm noticing I've got 1 nitrogen on the reactant side and 2 nitrogens on the product side. So I'm going to put a 2 right here. Okay, so now I've got 2 nitrogens both on the reactant and product side. Okay, so now we're on to step 3. So we're going to balance oxygen by adding water to the side that has the least amount of oxygen. Okay, so keep in mind this step is if it is necessary. So looking at our first reaction, well, there's no oxygen on either side, so I don't need to balance the oxygen because there's no oxygen there to balance. Okay, but for the second reaction, so I'm looking and I'm noticing, okay, I've got 2 times 3 oxygens, so that's 6 oxygens, and I've got 1 oxygen on the product side. Okay, so I need to add water to the side that has the least amount of oxygen, so I'm going to go plus over here, so I need 5 waters. So now I have 6 oxygens on both sides. All right, step number 4, we got to balance out the hydrogen, so I'll do that in green. All right, so first reaction, again, this step is if it's necessary. Since there's no hydrogens, I'm not going to add H+. Okay, but for the second reaction, I've got no hydrogens on the reactant side, but I've got 5 times 2, so I've got 10 hydrogens on the product side. So I'm going to add 10 H+ ions over to the reactant side. Okay, so hydrogens are balanced. Now what I'm going to do is I'm going to balance out the charges by adding electrons here. Okay, so I'm running out of colors here, so I think I'll have to do that. We'll just say we'll keep on doing it with green. Okay, so looking at the reactant side, I have 2 times -1, so that's -2 coming from the nitrate ions, and then I have plus 10 coming from the hydrogen ions here. Okay, so that's going to give me a total charge of plus 8 on the reactant side. Now on the product side, both of these compounds are neutral, so that's a 0 total charge on the product side. So now I got to go to the more positive of the 2 sides and add my electrons there. So I'm going to add 8 electrons here, so that would be plus 8 minus 8. So that'll give me a neutral charge on my reactant side. Okay, same as the product side. Now, I kind of skipped over the first reaction, so I should do that as well to this first reaction here. So zinc solid has a neutral charge, whereas zinc 2+ has a +2 charge. So I do have to add electrons to the more positive sides, and I'm going to add 2 electrons so that both sides are neutral. Okay. And then I also didn't put a state for my zinc ions. Okay, so whatever you do, don't forget about your states. Okay, so now at this point, we're at step 6, where we're going to add the 2 half reactions together so that the electrons cancel out. So I'll just do that in purple here. Okay, actually, I could do that in dark blue. I haven't used dark blue just yet. There we go. Okay, so we're at the stage where we're asking ourselves, what's the lowest common multiple between 8 and 2? Well, that's going to be 8. So that means I'm going to have to times my first reaction by 4, and I got to make sure to multiply everything in this reaction by 4. So that's going to be 4 zincs, 4 zinc 2+ ions, and then 2 times 4 is going to be 8 electrons. Okay, so now we have our electrons. We have equal amounts, but on opposite sides of the reaction arrows, so they cancel out. Okay, and I'm looking to see if anything else cancels out, but it doesn't look like we have anything else. So that means I can go ahead and write my net reaction. So 4 zinc solid plus 2 nitrates plus 10 H plus ions produces 4 zinc 2 plus aqueous plus N2O gas plus 5 water. Okay, so don't forget states, charges, coefficients, don't forget any of that there. Another thing that you're going to look out for, just to tell you if you're on the right track or not, is you're going to want to make sure that you have one reaction gaining electrons and one reaction losing electrons. If you have two reactions that are gaining electrons, you're doing something wrong. If you have two reactions that are losing electrons, you're doing something wrong. For redox reactions, you have to have one half reaction reducing, the other half oxidizing. Okay, that's why they're called redox, because it's a combination of reduction and oxidation. Okay, so 63 is kind of similar to 62, so I'm gonna skip ahead to 64 and we'll try that. So again, I'm just ignoring our H plus ions and water, and I'm just picking out what looks similar on the reactant and product side. So permanganate looks similar to the manganese ions, so we'll use that to create one of our half reactions. Okay, and then sulfite and sulfate, they look pretty similar. So again, I'm lining up these reaction arrows just to make it easy to see what cancels out. Okay, so I'm going to go through and balance where I can. So, right, I used blue to balance out anything that wasn't oxygen or hydrogen. So looking at the first reaction, I got one manganese coming in, one manganese coming out. So that's balanced. For the next reaction, I've got one sulfur going in, one coming out. Those are balanced. Okay, moving on to step 3, we need to balance the oxygen. So I used pink for that. So for the first reaction, I've got 4 oxygens on the reactant side and none on the product side. So I need to add my waters where there's the least amount of oxygen. So there we go. Now we have 4 oxygen on both the reactant and product side for the first reaction. Looking at the second reaction, I've got 3 oxygens on the reactant side, 4 on the product side. So I'm going to add my water over here. Okay, so now I've got 4 on both sides. All right, next step, we're going to balance out the hydrogens by adding H+. So looking at the first reaction, we've got 8 hydrogens on the product side, because 4 times 2, that's 8. And we've got no hydrogens on the reactant side. So I'm going to add 8 H+, aqueous, over here on my reactant side. So that's done for the first reaction. Now for the second reaction, looks like I've got 2 hydrogens right there and none on the product side. So I'm going to go plus 2H+, aqueous. Okay. So next I got to balance out the charges. So for the first reaction, I've got 1 minus coming from the permanganate ions, plus 8 coming from the hydrogen ions. So that's going to give me plus 7. Okay, and then on my product side, looks like I just have plus 2 coming from the manganese ion. So I got to go to the more positive side, and that's where I need to add my electrons. So if I go 7 minus 5, that's going to give me plus 2. So I need to add those 5 electrons. And there we go. So first reaction, the charges are balanced. Let's do the same for the second reaction. So we got -2 coming from the sulfate and 0 coming from water, so just -2 charge on the reactant side, and we have a -2 coming from, just in case I said that was sulfate ions, I meant to say sulfite ions. These are sulfate ions, so I've got a -2 charge coming from that, and then I have 2 times 1 plus, so +2 coming from the hydrogen ions, so I've got a neutral charge overall from the product side, so I gotta go to the more positive side and add my electrons there. So if I go +2 electrons, that would be 0 minus 2 to give me -2, so both sides now have a -2 charge. Okay. Now the last step is we need to add the two half reactions together so that the electrons cancel out. Okay, so I'm looking and I'm saying, okay, we've got electrons on the product side and reactant side. That's a good sign. Now I got to say to myself, okay, lowest common multiple between 5 and 2, that's going to be 10. So I need to multiply everything in the first reaction by 2. So it's going to be 2, 16, 2, and 8. Now for the second reaction, I need to multiply everything by 5. So that's going to be 5 sulfites, 5 sulfate ions, 5 times 2, so 10 hydrogen ions, and 10 electrons. Okay. Oh, and I didn't apply the multiply by 2 to my electrons, but I'm just catching that now. So again, the most common mistake is to not multiply everything in the reaction by what you say you're going to multiply it by. That's the most common mistake here. Okay, so the electrons, they cancel out. Okay, now I'm looking to see, okay, what else cancels out? So I'm noticing that I've got the same substance. So the hydrogen ions, I have those on equal and opposite sides. So these are going to subtract, and where the hydrogens are going to end up, they're going to end up on the reactant side in my net reaction, because there's more hydrogens on the reactant side in this first reaction compared to on the product side. Okay, so we're going to be going 16 minus 10 to figure out the net amount of hydrogens here. So I'm just going to do that really quick, and then I'll talk about the waters. So 2 permanganate ions plus 6 H plus ions. Okay. So again, we're just subtracting 16 minus 10 to deal with that. Okay, so moving on to the second equation. So we've got 5 sulfites. There's nothing to cancel those out. So I'm just going to write that. Okay, and now we got to talk about the waters here. So the waters in our net reaction, they're going to end up on the product side. Why? Because there's more waters on the product side. And how we're going to get the net amount is we're going to go 8 minus 1, because there's 8 waters in our first reaction on the product side, but only 1 water on the reactant side for our second reaction. Okay, so we're going 8 minus 1 there. Okay, so writing the net reaction, the products for it, going to be 2 manganese ions plus, so 8 minus 1, that's 7 waters, plus, so now I'm in the products for the second reaction, 5 sulfate ions, and the rest canceled out, so don't need to worry about that. Okay, so there you have it. Make sure to watch out for any substances that you have both on the reactant and product side, because they're either going to completely cancel out, or you're going to have to subtract one amount from the other to get the amount of that substance in your net reaction there. So before I end this video, let's just add that as a little side note here. So when canceling out, like, yes, the electrons, they must cancel out, but also you can't have duplicate species on both the reactant side and the product side. So you can't have water both on the reactant and product side of your net reaction. Okay, you can't have H+ ions both on the reactant and product side. Okay. So reaction, I'm going to abbreviate to RXN. Okay, so you can't have H+ ions and water on both sides of the reaction arrow. You're going to need to cancel out the repeat chemical species for each species. So mostly this pertains to H+ ions and water, but just make sure to check through each chemical species involved in both of your reactions to make sure there isn't anything else. But the vast majority of the time it's going to be our hydrogen ions as well as water. Okay, and as a reminder with what I said for the beginning of this video here, both for this page and for the previous page, you're not looking at page 7 of the data booklet to get the half reactions. Okay, so let's add that also to the previous page here. So RXN, just this means reactions.